Morning. How are you? This is a cool time for Swift. How many of you have been writing in Swift so far? Good answer. How many of you were in ObjectiveC before that? Better answer. I have nothing bad to say about ObjectiveC. In fact, I'm going to show a little on the screen. How many of you come from Java, C#? Okay, so you basically come from ObjectiveC. That was sort of the origin of those languages. Such a cool time. Swift was open sourced just a few months ago, and already you're seeing it on Linux, and IBM's getting involved with the server side. Swift, people are talking about it on devices, and it's running on Raspberry Pis and robots everywhere. And then news last week that it might become a first-class development language for Android as well, which is really interesting. So here's the world we came from. ObjectiveC was built on top of C, so there were some constraints. ObjectiveC is from the 80s, long before there was a Java or C#, and so some things here might look old-fashioned, but man, it was kind of fun to write in this language. One of the things I do miss about Swift is we don't have header files, and you might think, oh, I hate header files. But one nice thing is over the years, in the last 4 or 5 years, header files have been shrinking as we move more things inside of the class extension. And so the header file is where we said, here's my public interface. And there's no real way to do that in Swift, and that's kind of a shame. So we used to declare things that we could do to the outside world in a header file, and then we would go ahead and implement them inside of our implementation file in a separate file, but we would have this private interface that we called the class extension, and then the implementation would be where we implemented these guys. And you know, people were afraid of square brackets and things like that, but you know, colons were much more scary. Our Swift version of the same exact thing brings everything into one file. There is no header file. We're not importing individual header files anymore. We're importing modules. And if you've been around, and a bunch you have, ObjectiveC for a while, you've actually noticed ObjectiveC has been changing over the last 4 or 5 years. And as you look at Swift, you can say, oh, that's why they changed it. They were certainly moving towards Swift. And so everything from imports on. I want to look at a little more of this code, and then we'll talk about where Swift is going and sort of give you what you're here for. But you know, in ObjectiveC, if I was picking a random answer, it might look like this, and in Swift, it might look like this. So one of the nice things about Swift is it's more compact, less wordy, more clear what we're doing. Just to go over this more particularly, in ObjectiveC, you know, it comes from Smalltalk. We have to say who self is all the time, who are we calling these things on, whereas in Swift we have more of the Java C# view of this. We only mention self if we need to disambiguate something. Count and things like this were a method call, and method calls were inside of square brackets, so you sent a message to a receiver, and it was very big for us to think about that. But you know, count we wanted to think of as more of a property, and that took a long time for us to get there. The smallest thing that annoys people is the semicolon. Semicolons are optional in Swift, but I don't know anybody that uses them. The only reason that they are still optional is you can have more than one statement on a line and you need them to separate. So the other thing is, until recently, we couldn't actually call elements of an array this way. We used to have to use object at index. And so as we moved towards Swift, our syntax was getting nicer and nicer. And then one of the most striking differences between ObjectiveC and Swift for me is the return type for a method doesn't go there anymore, it goes there. And at first that just looks wrong, because all these languages that you've been brought up on, you know, put the return type where God intended, and here Swift has moved it there, but it nests really nicely. So if any of you have done work with blocks and had to nest blocks or declare a block and then use a block, these nest so much nicer, because in Swift every function is a closure. And so this will be something you do a lot. And so that's sort of the present view of Swift. And so you know, as we look to the future, some of it is just our habits need to change. So how many of you come from functional programming? Even the ones that do only raised it this high. So we'll take a moment to talk about that. If you come from an object-oriented language, you're used to doing things like this. If I have to move an element of an array from one position to another, maybe you built it on top of a method that removes an answer, and it just asks our underlying array to remove the object and then saves the result. And then if I have to insert something, I say, well, take the thing you have to insert and just insert into the array. And this depends on array being a reference type, where I can sort of point to it from all over. And now when it's time to move, we do this trick where we take the answer we're going to move and we store it somewhere. We just put it aside somewhere, and now we can remove the old answer. And we say, well, we removed that old answer because we're safe. We've saved the old answer somewhere, and now we've cleaned up the array, and now we insert that thing that we set aside back where we need it, and now we have moved something to a new position. And that's not how we think of it at all in a functional language. So in Swift, the way we think of moving an answer is we have this remove answer, and instead of adjusting the array, we give you a whole new object back, and it's a value type. And so we don't change things, there's no side effects, we don't change things under you. We say, here is the newly changed object, and you can either hold on to both of them or get rid of one. And so we create a local mutable copy. And so we make things as immutable as possible. So we make a very local mutable copy, we change that local copy, and then we create you a whole new object with that changed copy. And this pattern of making this local copy and giving you a new copy occurs again and again in functional programming. And so you're going to see that in insert as well. And we have this mutable copy and returning a new copy, and all we do inside is we insert. And so when you remove, we remove from the mutable, and we insert. But here's the payoff, and this is just so striking. When it's time to move the answer, we don't have to save a temporary copy, because we're making these new instances everywhere. And so we just say, build me a new thing where you've removed the old value, and then insert the new guy. And this looks wrong, and you're sure it's wrong. And you make these notes on your little napkins up in your hotel room, and you trace what happens when this, and the whole magic is that you haven't changed anything because nothing is mutable, so you still have that original value in your original array until you finish this line. And so this is sort of the functional move that you're going to have to go through as you learn Swift. Swift is a protocol-oriented language. They make a big point of that. Have you guys seen the Dub videos? The famous Krusty video? So if you've not watched last year's WWDC videos, that's one of the nice things that Apple does now that their conference sells out, is the videos have been available usually by that afternoon. And the one that the people talk about as the Krusty talk was written by the guy who writes the Swift Standard Library. That's Dave Abraham. He comes from the C++ world, and he does this talk about focusing on protocols. So that talk, the What's New in Swift talk, and the value types talk are the three that you should watch from last year. Coming up, we expect in June will be this year's Dub, and again, they'll tell us what's new this year. But now that Swift is open source, we kind of know the future. They're talking about it openly. And when they first opened up Swift, people looked at the license and they started sniping at it, and they started talking about, well, it doesn't have the same license that Java has. It doesn't have, so it can't be right. And yet, very quickly, they started taking suggestions from the community, pull requests from the community. There are things in shipping Swift code now that came outside of Apple, which, if you've been around Apple for a while, is stunning. And so despite the license and that you hate their license and they're just not real in your world, this is truly an open process, and it's been stunning. The other part of the openness is the guys writing the code, the teams writing the code are on the list. And so when someone suggests something, they'll say something like, well, we actually considered that in the beginning, and here's why we want a different way. And so you're getting a lot of the thinking behind the decisions they made in Swift. When Swift first shipped, I don't know if you remember, those of you that have been around a while, arrays, immutable arrays, you couldn't increase their size or decrease their size, but you could change the value of the elements in it. And the community had a fit. They said, if it's immutable, it should be immutable. And they changed it. And that was sort of the first sign that they were listening. Here are the changes that are coming in Swift 3. Some of them is access. So right now, the default level of access is internal. If you don't label something as having public or private, it is visible within a module. So if you're writing a library and you want things to be visible throughout that library or framework, but you don't want anyone else to see it, the default value is internal. If you want someone who is importing that framework to be able to see it, you make it public. And private is the one that confuses a lot of newcomers to Swift, because private means private to the file it's in. And although that turned out to be a very valuable concept, it was very confusing to people that were coming to the language from somewhere else. Internal wasn't quite package private, what they thought of. Public did mean what people think, but it was the private that just didn't feel right. And so in Swift 3, there will be another term, which is file private. And file private will say, this is private only to this file. And then private will now become what we think of as private, which is private to this class. And so they are adding a fourth level of access. People wanted other things that meant something like protected means to us or friendly, and those didn't make it in, but for now they're increasing this while keeping file private. One of the strangest changes is sort and sorted. In Swift 1, we had sort and sorted. And so if you gave me an array and told me to sort it, or if you gave me an array and gave it the sorted, it did two different things. If you asked an array to sort, it would take the array you gave it and rearrange it. It would sort it in place. And if you asked it sorted, it would leave the original array alone, and it would give you a new array that had been sorted. And no one could remember which was which. And so in Swift 2, they changed it to sort in place and sort. And you might have noticed that sort changed meaning between Swift 1 and Swift 2. Now sort means the one that gives you a new array. And sort in place is the one that changes the elements of the array. Well, in Swift 3, we're going back to this. And sort will change meaning again. And it's unfortunate, but it follows one of their naming conventions, which is name methods according to their side effects. And so those without side effects are going to read as a noun phrase. So you say, X, calculate the distance to, or number, give me your successor. And so that is something without a side effect. It doesn't change X, it doesn't change I. And things that do have side effects should be read as a verb phrase. So sorting in place becomes sort because I am changing this array. I'm appending to this array. And so this has gotten a lot of discussion. It's nice because the guy that wrote the Swift Standard Libraries, who came up with sort in place, is defending this new version, but saying, really, it's because he lost the argument. But it's nice to see that they are going for some sort of a consistency. And so if you are not changing the thing, then the counterpart to sort will either be sorted or sorting. And they would like that to be done consistently throughout the language. The problem they're running into is that some terms are just common, like map and filter and reduce. Map and filter and reduce are sort of terms of art. So some people are arguing if you follow your rule, it should be mapped and filtered and reduced. It's getting interesting on the list. And so sort and sorted is an oddity that we're just going to have to live with. The other place they're running into problems is the set operations. They don't want unioned and intersected, and so they're debating that right now too. So here's what is coming in Swift 3, and I don't know if you can see what's kind of different about that, but keywords are being allowed to be used as labels. The word for is a keyword in Swift, the word in is a keyword, but you're seeing prepositions get used a lot. And so the fact that I can say calculate revenue for this in this, very different. So keywords are now allowed in Swift. This is one that I don't know that I'll get used to. Let me go back. You see that dollars is done in lowercase here. They would like you to change enumerations from being enumerated in uppercase to enumerated in lowercase. And this just doesn't look right to anybody I know. And so instead of this, they want us to now do this. and it makes me weep. This just looks wrong. But I digress. The other thing is, it is currently legal to refer to items in your list, in your enumeration, without a dot. So you can see that I can do case dollars instead of case dot dollars. And this is currently legal. As of Swift 3, this will be illegal, and you'll have to use the dot. One of the nice things is the team that is leading the rewriting of Swift is also the team responsible for the tools. So in most of these, they're able to provide you with automatic refactoring to get this right. So they're asking you, even though it's legal both ways, start using the dot, because starting in Swift 3, you'll only be able to use the dot. So this is an odd time, because I'd like to encourage you to come to Swift, but this fall, this is all going to break code. It's still a great time to come to Swift. So much is going on right now. Their goal with Swift 3 is to get binary compatibility. Right now, if you build an iOS app, it ships with a little bit of binary, like 2 megs worth, that is the actual Swift diff in the runtime, so you know which Swift version you shipped with. Starting this fall, you won't ship with that, so it won't bloat your app, and so Swift will be a little more stable. There are some people that have proposed getting rid of the switch on self, because you have to switch on self all the time in enumerations, and that didn't make it. So a lot of times things have been proposed and they haven't made it. More things have made it in than haven't. This is kind of cool. You can now declare variables in case labels, and you can use that same pattern. So you can say, you know, what I'd really like to do is I'd like to pull out the int, even if in case 1 the int comes first, and in case 2 the int comes second. So I'm going to use that same variable. I'm going to use that x to refer to the int wherever it is. And so in my switch statement, what I'm really doing is I'm binding to that int wherever it is, and I'm letting the float be the other value. And so even if it's not in the same position, this is something you'll be able to do in Swift 3, which will simplify. You'll have fewer case statements to go through. In Swift 2, you would need a separate case for case 1 and for case 2, and to bind each one, even though you're doing the same exact thing with the int wherever you pull it from. So too fast, too slow? You're not talking to me? One of the things that Apple has stressed in the last few years, and is anyone new to working with Apple frameworks, Apple platforms? So if you've come from Java, the word deprecated means something different to you than it means to us. In Java, deprecated means, yeah, it's never going away. Apple controls the hardware and the software, so usually when they tell us stop using this, it's because they're not telling us what's coming in the hardware, but it's something that needs something different, or they're changing the language. And so when they give us these pieces of advice, it's because they know where they're headed and they can sort of control our destiny. So for a while they've said, if you have a bunch of constants and they're grouped the same, could you please give them the same sort of starting point? And one of the nice things they're doing in Swift 3, a lot of Apple's work is, well, how do we do stuff in Objective-C and bring it into Swift nicely so that we can work from either language? This becomes an enumeration where that prefix that's common to all of them is the name of the enumeration, and each of the cases, of course it will become lowercase soon, but each of the cases will be sort of the end of it. So going back a slide, this then becomes an enumeration in Swift. And one of the nice things about this is if you've got this type, you just hit a dot and it will show you all the possible completions. And you're seeing that now. If you have a button and you're setting the title, the state, you put a dot there and it says normal, highlighted, whatever. If you're doing an animation, you do a dot, it will tell you the fade or from the right. So it's nice that this will give you a lot of help as you're writing code. Not many of you come from functional programming, and so you won't miss this. This, for people that come from Haskell, is something that's sort of essential to Haskell. This currying says I give it one argument at a time, and so I would call this and say the name of the function and give it the first int, and then give it the second int, instead of having a parentheses where I have the first int, comma, the second int. And this is useful in functional programming. We lose this version, but we keep this version. And if you're not used to seeing arrows at the end, don't panic. All this says is I have a function named curried. It takes an int, and what it returns is a function. It returns a function that takes an int and returns an int. And so those two arrows on the right side, you're not supposed to panic. That first arrow says, well, here's what I return, and everything after that's what you return. You return a function from an int to an int. And so in this case, what comes after the return is the int you return. Those of you in Java have your lambdas. Those of you in C# have something that looks fairly similar to this. So it is becoming familiar in several languages. And so I will return this, and then I can call it one at a time. Curried 7 returns a function, and it's a function that expects me to give it an int. And so I can still pass behavior around the system. It's something we can do in blocks now in Objective-C, but the syntax would just look so ugly, I refuse to put it on a slide. When you call a function in Swift, by default, it makes an immutable copy of its parameters. So you are not changing what you pass to it, it is making an immutable copy of the parameters. So if inside you want to change the value of input, you have to mark it as mutable. So when I put var there, var says when I call changes, it will make a mutable copy of what I pass to it. This is going away in Swift 3. In Swift 3, they've decided that you should, instead of calling var here, you should have to, or let, you should have to make your own explicit mutable copy inside. And although this is more verbose, they feel it makes the language more readable. And so you'll see people will have to explicitly make a mutable copy of input that got placed in, and then vary that mutable input. If you remember back, that's how I did my insert and remove when I was showing the Swift version of that. I made a mutable copy, I inserted or removed, and then I returned something new. So this is the standard for Swift 3. There's something else though, because you say, well, we're creating this new mutable input that is just a mutable version of input. This is one of the few cases that Apple recommends shadowing names. It's a little bit confusing because the parameter input is the one on the right and the new input is the one on the left. Input has two different meanings here. In general, this is very confusing. Up to you whether you like it or not. If you don't, just name them different things. So going back a slide, the new input took the place of the mutable input in those three positions. And so some people find this easier. I would find it easier if it was just var input and we didn't have the equals input there. Yeah?
Was there anything that's replacing the var? I mean,
this is replacing the var.
Inside local scope?
Oh, no. var is not going away generally. var is only going away as a label of the parameter.
Right, but does that, you'll have to pardon my knowledge, I'm not like a Swift master, I've done a little bit with it. Is that letting you essentially the equivalent of a C++ pointer or C pointer?
No.
Send a return value out?
No. So this only changes it locally within the scope of this does not change anything outside the scope of the function. However, that brings me to the next point. So are you good with that then? So what you're thinking of, we've done up to now with an in-out. In-out says, don't make a copy, actually change the thing that's being passed in. And so the contract here says, if I pass you a parameter that changes, you're going to change that. So it's more the pointer. This is not going away, but it is moving. Not far, it's moving to there. They felt it was more of a declaration of the type of thing rather than the variable name. So it's just moving over a little bit. We can still find it. But that accomplishes, in that case, I'm actually changing input, and so input equals input times 2 changes whatever variable you passed in. This was surprisingly upsetting to people. This is going away. Increment and decrement operators that come before and after, going away. And the reason they're going away is people were making mistakes with them. They were forgetting, wait, does this get done before or after? And so you have to explicitly say something like this now. Because now you can say, okay, I see where X is changing. And so, like it or not, this is very much the attitude of Swift. You should be able to find the things that go wrong with your code at the time you're writing it, not at the time that it's running. So with Objective-C, a lot of things crash, does not respond to selector, exec bad access, things like that. With Swift, they take so Java was created with the idea, if you listen to Bill Joy, that as much should go wrong at compile time, at development time, and Swift is really embracing that and taking that further. They'd like their code to be easier to reason about. So plus plus, minus minus going away, and that really leads to the next thing that has people still upset. C-style for loops are gone. So we have fast enumeration, we have enumeration over a range, we have all sorts of enumerations, but we are losing this for loop. And that went away in Swift 2.2. People that are asking for it to come back are being told that would have been a good reason for us not to get rid of it in the first place, but now that it's gone, the burden is you really have to convince us to bring it back. And so this was the first proposal by a community member that got accepted. This came from Erica Sadoun. So gone. So we can use this. We can stride. We can use all sorts of for loops, but our classic C-style for loop. And the reasoning was, for the most part, why don't we treat this as a language that people will be coming to for many years and not hold on to these constructs that are 30, 40 years old, that we hold on to them just because. You know, when Java was first created, a lot of the argument was it's very familiar to C-style programmers. And so I don't know how many of you were around in the beginning of Java, but in the beginning of Java, a lot of Java looked like C. And it took a long time for people to embrace the OO side of it, including some of the team members. Someone said, boy, this is confusing. So in Java and C#, you don't have to use this if it can be figured out which is which. And so someone said, this is confusing. I want you always to have to use self the way we do in Objective-C. I want you always to have to do self so I know what's a property and what's a local variable, and this didn't make it. People said you can require it of your team, you can have it as house style, but you're not going to require it of anybody else. And so in this case, it is not required. Type alias has two different meanings in Swift. And so type alias is used as like a type def, just use this word in place of this other type. So for instance, in Objective-C, we use ns time interval, it's just a double, but when you use the word ns time interval, it is time measured in seconds. So that's that first meaning of type alias. And the second meaning is, I don't know what this type is, we'll fill it in later. And it was observed that these are completely different meanings for the same word, and so let's change one of them to associated type. So if it's something I'm going to fill in later, we're going to use the word associated type. And so associated type and type alias. Someone pointed out, why don't we camel case these? And someone else said, yeah, that's not going to happen. That someone else was Chris Latner, the guy that wrote the language, who said, you know, nothing's impossible, but the odds of this becoming lower camel cased, near zero. So in Objective-C, we can send messages by just giving you the name of the method being sent. It's very easy to do. So in Swift, we used to do this way by just sending the method name in quotes. That's going away. In fact, it has gone away. We have to use this pound selector to be very specific about what the name of the method is, what class it belongs to, just to disambiguate. So we're not sending methods around by their names anymore. Those of you coming from Objective-C, that should look familiar. That looks like @selector. So it's not something tremendously new and unusual for us. Question? Okay. So this is so puzzling that sometimes we just write things out and there's nothing in between them, like this operator has left associativity and its precedence is 120. Wouldn't it be nice to actually say the associativity equals left and not just write this random collection of words? And so in Swift 3, that will be required. This might be one of the hardest things for newcomers to Swift to get used to. In this function, increase our number's a label, delta's a label. It takes 2 ints, increase our number and delta, but if you look in the call, even though we use that second label, we don't use the first label. Why? Because Apple hates you. This used to be worse because it used to be different in functions, and then when you brought the function inside a class, it would behave differently inside as a method. And the rule from Apple has been for a while, if it's a method, we drop the first label and we keep every other label. And the reasoning from them was, well, most of our methods in the world have only one or no parameters, so wouldn't this be easier if we could do it this way? But it leads to this horrible inconsistency. And so starting in Swift 3, all labels will be treated the same, even the first one, and so this method will become increase by delta. Now, you can always suppress a parameter. We've always been able to do that. You'll be able to do that now using the underscore, and so if you prefer to suppress, you can, but people will make fun of you and say, oh, you must be a Java developer. So we don't tend to suppress labels except in very specific cases. I know, way to harangue the crowd. The underscore you can always use to get rid of it. The other thing that we're going to tend to do is Swift 3 is really big on prepositions. And so instead of the method being called increase by, you'll see that we will move the by inside. And so you'll see it will be increased. By will be the label, and the delta will be the internal name for that. So you're seeing a lot of methods become that. And although it looks kind of goofy at first, it's really readable. It's the way we speak. And so take x and increase by 6. So that I think will grow on you. These come out of a broader API design guidelines. Apple's put a lot of thought into it. They've responded to the community. They've posted them on swift.org. For the most part, I'm pretty happy with these design guidelines. One of the design guidelines is in Swift 1, so many things were done with free functions, and now Swift says prefer methods to free functions. And one of the things that has enabled that, again, if you go back to that talk I referenced at DubDub, one of the things that enables that is protocols, what Java and C# calls interfaces, now can have implementation of methods. And so you can have not just method signatures in your protocols, but you can have implementations, and so that allows us to bring things in as methods that used to have to be free functions. And so that's one of the things that you'll see. And so in this case, no one is sort of responsible for calculating min, so this is an exception. You'll just use a function for this because it's no one calculating the min, so it's not something dot min. So this is a case where free function is acceptable. I'm taking the min of 3 numbers, that's a function. Another exception is here, the function just, it's an unconstrained generic, it's just print. It's nobody doing the printing. And so print x is another case. And then a third case is when the function is just known a certain way. It's part of the canon, there's prior art. I could do this as math.signx, but signx is pretty clear. So other than that, we're going to try to move free functions into classes, into structs, into enums. And even into protocols. Casing conventions, even when we hate them because enumerations are now lowercase. Methods can share a base name. This is mostly good except if you do iOS programming and you use table views. All the methods are named table view and all the changes are sort of inside. So when they do analogous things, it's good. All the table view methods, if you look, are a little confusing that way, but we're on the way. Parameter names become very important. And so, for instance, if I have my move, I'm moving from my starting index to my ending index. Internally, those are great names. Internally now, I don't have to wonder which index is which. We don't just call them A and B. In the early days of teaching Java, I had a student that would name his first variable in the whole class A, and the next one B, and the next one C. So A could be a label, and B would be a button, and just awesome. Remember, we write for each other. This is something that is available in Swift that is pretty nice, is that parameters can have default values, and we don't do this enough. And so we can give a default value of world. Even more important is this example where we're initializing an object and it may have a value, it might not have a value. Well, initialize it to nil then. You know, the default value is nil, and it's only when you actually want to give someone's hometown a value that it has one. If you don't provide a hometown, then its value is automatically nil. And so you can imagine you have these inits with lots of parameters, and it doesn't matter which ones they set. In Swift, because the parameters are named, we don't have to do what we do in other languages, which is as soon as we hit our first, then the rest are assumed to be default values. We can have default values sort of sprinkled through. We do put our default values at the end, but it doesn't matter which ones you're agreeing to set as you go. In the case of min, we wouldn't label our arguments. I'm taking the min of these numbers. It doesn't matter which one's the first one, I give it in the second, and so I wouldn't use argument labels in this case. I use argument labels when they matter. I love their moving to prepositions where move from the starting index to the ending index, because the way you evaluate a method name is you look at the call site. How does it look when I'm calling it? And so this goes way back in the beginning of Objective-C. In the mid-'80s, Brad Cox, the guy that created Objective-C, said, you know, before you write a method, write the code that uses that method. Before you write a class, write the code that uses that class. I mean, today we call that unit testing, and that's how we design with unit testing. But it's the same thing here. Look at the call site and really spend time thinking about this method. I'm moving from here to there. Argument labels, sometimes I do have these exceptions, like I said. If there's no difference, the min of this order, the other order, there's no need for them to have a label. Also, if I have these inits where I'm creating a double from an int, I don't have to do what we used to do in Objective-C, ns number with int. I just ns number and give it an int, and it'll do the right thing. So if you're giving it an int to turn into a double, for those of you that haven't played with Swift yet, one of the things people hate about Swift is that you don't get automatic promotion. And so if you've got an int or a long or whatever you've got, you can't automatically promote from one type to another because there are no primitives in Swift. These are implemented as structs. And so you're creating a new instance of a double using the value of the int. You can't just say, well, I've got this int that is 5 and this double that is 4.3 and I want to multiply them. You're not going to get automatic promotion. So if you're doing a lot of graphics code, that's something that's galling. And so the way that Apple does this is they use that underscore to suppress the name of that input, and so now you would call it saying double from my number and get it that way. When the preposition applies to the whole, I just love when they write stuff like this. And so I've got this move from starting index to ending index. That the prepositions don't refer to the whole. The from refers to the first index, and the to is the second index. But if I've got a point and I'm moving it to this other point, then we'll put the to up front, and I'm moving to the point 3, 4. And so I would call this by saying move to 3, 4, not x:3, y:4, or x: if you want. So the preposition, when it applies to the whole, we move it up front. In this case, remove boxes having length, we can leave it there. So questions, comments, complaints, that's our world of Swift. Yeah. Oh wait, I got a guy with a mic who needs to come out.
Sorry, 1 second.
He told me to warn him and I didn't. Oh. It's right here. He's not, he just found your mic. Isn't that enough?
I'm just the mic finder.
Anybody?
In the back.
Sorry, I actually didn't realize you were done, but great talk, appreciate it. Something I was just gonna throw in, you mentioned the default arguments. Something that I learned recently about those is that they're actually, you don't have to just use a quote unquote primitive there. They're actually they're lazily evaluated when and if they're needed. So you can put like an emitter or a little bit of code there that does something and produces a value. So it's a pretty neat little feature.
It is kind of neat. The other thing that I'm beginning to use more is did set and will set, particularly if you do GUI coding. If you've got an outlet to something, you want something to happen once it actually has been set by connecting to the storyboard. It's nice to put that in the did set instead of filling up your view did load. So there's a lot of nice ways to move code around now. Here.
So with all these changes, some of them look pretty breaking. Do you have an idea of, what sort of effort people are looking at to migrate from Swift 2 to Swift 3?
So it's going to be effort. And they've been very clear that this is going to be breaking, and as a fan of the language, I'm really happy because I've been around languages where they were afraid to break things, and it's still early days. And so I'm really glad that, in fact, so little things that are going to break are things like they want to remove redundancy. So if you want to create something that is black, you say UI_color.black color. They're changing it to UI_color.black. This will break code. But they think things like dismiss view controller animated, well, it only applies to view controllers, so it's dismiss animated. So they're making no bones about it. It's going to break code. It is going to require effort. They're going to try to provide tools. So they did that during the ARC migration, but the tools aren't going to do everything. And so it's going to be a painful migration, but I would rather they don't hold the language back. And the other thing is, at this point, they're already releasing early builds of Swift 3, and so you can go to the trunk and put them into Xcode. In June, when they release, let's say they call it Xcode 8, let's say they call it, iOS 10, we're going to have working versions of this. So over the summer, and if you have greenfield development, you're going to be working towards Swift 3 anyway. So the pain point is pretty much now, but following their patterns, iOS 10 will probably be out with new phones in September, and so that's where we expect Swift 3 to be close. No, but they made no bones about it. It's going to be painful right now, and they're sorry. Anybody else? We happy? We'll go get lunch before other groups.